T2.9. The EPA requires that the exhaust of each model of motor vehicle be tested for the level of several pollutants. The level of oxides of nitrogen in the exhaust of one light truck model was found to vary among individual trucks according to an approximately normal distribution, with mean mu equals 1.45 grams per mile driven and standard deviation sigma equals 0.40 grams per mile. Which of the following best estimates the proportion of light trucks of this model with NOx levels greater than 2 grams per mile? So we want the proportion greater than 2 grams per mile. All right. Now this is a multiple choice question, but I'm going to tackle it as if it were a free response question, taking you through all the different components that you would need to put in your answer. Okay. First thing that you want to do is you want to sketch a picture of the original distribution, so in units grams per mile. Okay, so this is approximately normal, the mean is 1.45, and the standard deviation is 0.40. Okay, we can label the mean 1.45, and we're going to label the boundary value. 2 grams is going to be somewhere to the right, maybe like about here. And then it does say the proportion that is greater than, meaning that we want to shade the right tail here. Okay. So now the goal of this problem is to figure out how much area is in this right tail. All right. Now we can't find it in this distribution, but if we standardize the distribution, then we can take advantage of table A. All right. So let's get the z-score here. All right. Value minus mean over SD. So the z-score will be 2 is the boundary value, 1.45 is the mean, and 0.40 is the standard deviation. All right, I'm just going to do the calculations off screen so I don't feel like toggling between tabs here. 2 minus 1.45 over 0.40. Okay, so I'm getting a z-score of 1.375. Okay, I'm going to round that up to 1.38. Okay, so this is rounded. It's approximate. Okay. The reason why I rounded is because I know that table A only goes to the hundredths place for the z-score. So yeah, that's why. Okay. Let's go ahead and draw the standardized distribution now. Okay, I'm just going to copy this. Nope, didn't want to move everything. Okay, undo that. Let's try that again. Duplicate. Okay. So now this is standardized, meaning that it has a mean of 0 and a standard deviation of 1. Okay, and then our z-score is 1.38. All right, so now what we've got to do is find table A. Here it is. Okay. All right, so we're looking for positive 1.38. All right, let's erase those previous marks. Okay, there's the 1.3, and all the way over there, that's the 8. So we're looking at 0.9162, or 91.62%, which doesn't seem right, but that's because table A gives you the area to the left. Okay, so the area in the left tail here is 0.9162. So the actual area that we want is going to be 1 minus 0.9162, which is equal to 0.0838, I believe. Okay, just over 8%. Okay. None of the answer choices are perfect matches, but B looks to be the closest match. Okay, 0.0846.